And are we capable yet of having sort of a space weather forecast in the same way that we have a weather forecast on Earth? Because, for example, if I were going to go, say, climb a mountain or cross an ocean, I would check the weather forecast beforehand. Is there an equivalent with space weather that that's starting to exist where, for example, before launching satellites or people, we can check and try to understand the coming environment better, or is that not yet possible?
Nope, NOAA, the National Oceanographic and Atmospheric Administration, is charged with making those forecasts. And just like there's a National Weather Service, there's the National Space Weather Prediction Center in Boulder, Colorado, that's charged with making forecasts of space weather. And they have lots of customers, airlines. As we have more and more transoceanic flights, if you make a great circle from mid-latitudes, like from China to the US, going over the pole is actually the shortest distance. And there are two impacts of going over the pole. One is you lose sight of ground stations. There's essentially nobody there, so you can't use your HF radio consistently. And also you're now at the polar regions. And the reason why the Aurora Borealis and Aurora Australis, or the northern and southern lights, are at high latitudes is because the charged particles can flow along the magnetic field. There's no Lorentz force acting on it, where if you remember from your physics class, there's a right-hand rule, QV cross B. So if the velocity of the charged particle is perpendicular to the magnetic field, there's a force that's going to try to deflect it. But if it's along it, it can move. And since the Earth is like a dipole, the field lines are coming in and out of the polar regions. So the charged particles get funneled into the atmosphere at the high latitude regions. And so the radiation environment over the poles is much higher than at mid latitudes. And so airline crews are considered by OSHA, our Occupational Safety and Health Administration, and the equivalent agency in Europe, as radiation workers. And so there are radiation monitors on all commercial aircraft, so they can monitor the dose. And everybody has dose limits for your career, as well as an annual dose limit. And so in one storm, you can get a yearly dose. And so instead of grounding that crew, and instead of pilots, what they would do if NOAA forecasts that there's going to be a geomagnetic storm, they'll go at a route that doesn't go across the poles. And that's a longer route, so it's more fuel. And so they don't want to do it, but they don't want to pay people to be not flying. So they do make forecasts. Power companies respond to forecasts to try to make the grid more resilient. And then communication and navigation, exploration depend on knowing what the Earth's magnetic field is. And when these storms happen, the Earth's magnetic field starts wiggling. And so if you're trying to use the Earth's field as a good compass during a storm, it doesn't work. Or if you're trying to look at oil exploration, and you're trying to discover different conductivity layers in the Earth, you don't want to do it during a geomagnetic storm.
Hey everyone, thank you for listening to this podcast episode. This is Michael.
This is Sam.
This is Tommy.
And this is Joe.
If you're listening to this on YouTube, make sure to like, subscribe, and share with your friends. And if you're listening on Apple Podcasts or Spotify, make sure to leave a review. All of the show notes can be found either in the description below or on our website. Thank you again for listening, and we'll see you next week with more Everything Astronomy.